we're going to review rational function graphs. We're going to especially focus on what happens at the discontinuities, where you have either vertical asymptotes, open dots on the graph, which are called removable discontinuities, or the horizontal asymptotes. So let's do 3 examples. First of all, to remind you, when you're looking at the denominator factors, when you have a vertical asymptote is when one of those factors does not cancel. If it doesn't cancel out, it gives you a vertical asymptote. Now, if it does cancel, if that factor cancels, it ends up with an open dot, or RD, removable discontinuity is the official term for that, on the graph. So let's look at this first one. This is a form we might have for a rational function where we have 4 over x plus 2 plus 5. This denominator doesn't reduce with anything, and since it doesn't reduce, we're going to take a vertical asymptote where that would equal 0, because remember, you can't have 0 in the denominator of a fraction. So if you put in -2 plus 2, that would be 0, so that's not allowed for a graph. So at x equals positive or -2, we're going to have a vertical asymptote. Now on this one, this number out here, the plus 5 that's by itself without a fraction, that's the horizontal asymptote. That's y equals 5, gives me my horizontal asymptote. Once I get my asymptotes on the graph, I then will graph this rational function on a graphing calculator and get the shape from the graphing calculator to draw the sketch. Let's take another example here. This one, notice, doesn't have a number being added, and so it's just a rational expression. The degree on top is larger than the degree on the bottom, so this is going to go off to infinity. Let's go ahead and take a look though what happens with the factorization. If I factor the numerator, I get x plus 2 times x plus 1. The x plus 2's reduce, because x plus 2 over x plus 2 is equal to 1, so you can take that out, and so I get just x plus 1. The graph of this rational function will look exactly like x plus 1, that line, with the exception of there's an open dot at that place where the factors cancel. At x equals -2, if I put -2, that would give me 0 there. I've got to put an open dot at x equals -2 on the graph to say that point's not allowed, but the rest of that line is, and that would be exactly what the graph would look like. So when you cancel those factors, you get an open dot at that x value of -2. Now, let's take a look at one where you get both a vertical asymptote and an open dot, and then we'll talk about horizontal asymptotes just briefly. So this rational function, notice that the degrees are the same, and so when I factor these, I get this one factored into these 2 binomials, this one factors into these 2. The x plus 4's are the same factor, they reduce. Because it reduces, you have an open dot at x equals the opposite of that number, -4. So at -4, I'm going to have an open dot. Whereas this x minus 4 in the denominator, it doesn't reduce with anything, and so that leads to a vertical asymptote at +4 for that. Now notice this x minus 5 doesn't have an asymptote. Don't try to set up an asymptote with the numerator factors. It's the denominator factors that lead to the vertical asymptotes or the open dots. Now, our horizontal asymptote. Here are the rules for horizontal asymptotes. If the numerator degree equals the denominator degree, which 2 and 2 are my degrees for the numerator and denominator, then you take the leading coefficient. Here it's 1 over 1 would give me a horizontal asymptote at 1. If this had been a 2x squared, it would have been 2 over 1, would have had a horizontal asymptote at 2. So at y equals 1, I draw a horizontal asymptote for my graph, and then I can look at my calculator to get the shape, draw this shape in, and when we get to -4, draw an open dot, and then keep going after that, and then this is the shape from the graphing calculator on the other side. Now the other things you look at for horizontal asymptotes is when the numerator degree is less than the denominator degree. So let's say that we didn't have the x squared minus, it'd just be x over x squared. When that numerator degree is smaller, then this will go to 0, The x-axis, or y equals 0, would be your horizontal asymptote. And lastly, if the numerator degree on top is larger, so say this would be a cube over a square, we don't have a horizontal asymptote. So we'd have to have a further discussion about what those asymptotes might look like. They might be a slant asymptote, might be a parabolic asymptote. That's for a different discussion, but you just don't have a horizontal line as an asymptote. So these are 3 examples to help you see some of the patterns for how to come up with your asymptotes, your open dots on your graphs, how to draw your graphs using your graphing calculator to come up with rational function graphs.